in this, Theorem 95, which says if two chords of a circle intersect inside the circle, then the product of the measures of the segments of one chord is equal to the product of the measures of the segments of the other chord. This is called the chord-chord power theorem. How confusing is that? But it doesn't have to be. This is basically what that says. If you have a circle and you have two chords that intersect inside the circle, then what I say is part times part is equal to part times part. In other words, this times this is equal to this times this. Does that make sense? I'm looking for, I had a couple of, here's a sample problem that we can do. That's not it. Ryan, get back in your seat, please. Okay, here we go. So, for instance, if we had 2, 6, and this was 3, and this was x, then what we could say is part times part is equal to part times part. So let's fill it in. What would we say? Are you thinking with me? Or y'all kind of thinking ahead? All right, I'm going to give you just a minute to figure out what this equation would look like. Was that long enough? Okay, so part times part. So 2 times 6 is equal to part times part is equal to 3x. So 12 is equal to 3x. Ta-da! 4 is equal to x. Da, 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 da. It's magic, isn't it? So what you see, kids, in this lesson, in previous lessons, we were focusing on angles and angle measures and arc measures. But now we're actually looking at chord lengths and tangent lengths. We're finding out how long this sucker is, all right? We're not looking at the angles anymore. We're looking at the actual length of the chords or tangents. So this was our first theorem. That was Theorem 95. Theorem 96 says, and I read you, if a tangent segment and a secant segment are drawn from an external point, stay tuned. Okay, I can't find, all right, how about purple? Let's go with purple. So here's what we've got. Oh my, isn't that attractive? We've got a tangent and a secant. And what I say, I call this part of the secant, it's outside of the circle. So I call this out, and then I call this the whole thing. So I say out times whole is equal to out times out. What the heck? And this is just another way of saying exactly what they've said. This is what the deal is. This part times the entire thing is equal to this times this. So what I say is out times whole is equal to out times out. See, because it really doesn't extend beyond that. I didn't draw that very well, but it's a tangent. So this is the point of tangency right there. So let's put numbers in this. Let's say that this part was 2 and that this part was 16 and we were looking for y. So what we would say is that out times whole is equal to out times out. Okay? Now then, I'm going to give you a second, and I'll put on some background music while you focus and you think of what that equation is going to look like. Da, 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 da. This is background music. Da, 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 da. Are y'all singing with me? Okay, you ready? So out times whole. Out, and there's a really common mistake, and I'm going to show it to you. Out is 2. What is whole? Be careful, kids, because this is the biggest mistake kids make on these problems. because you want to put 16 in there, don't you? But does 16 represent that whole thing? No, heck no. What represents that whole thing is that part plus that part. So out times whole is going to be 18 is equal to out times out. Y times y. And what we end up getting there, then, 2 times 18, 36, is equal to y squared. Take the square root of both of those, and we end up getting that 6 is equal to y. Ta-da! 7. If two secant segments are drawn from an external point to a circle, then the product of the measures of one secant segment and its external part is equal to the product of the measures of the other secant segment and its external part. And this is called the secant-secant power theorem. Man, they make it so darn hard, and it isn't, okay? So let's draw that picture. I'm going to go right up here. I think you can see that, because see, this is my border here. So I'm going to draw this one right up here. And basically, this looks like this. We've got two secants coming through. Now, in this situation, what that theorem just said was that this times the whole thing is equal to this times the whole thing. So again, I say out times whole is equal to out times whole. Let's put numbers in this. Let's say that this was 4 and this was 8. This is 3, and we're looking for x. Okay? Here goes the background music. You see if you can figure out what this equation looks like. Da, 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 da. Okay, are you ready? So what is this equation going to look like? Out times whole. Remember, there's a common mistake, and you're not going to make it, because we learned about it over here. So we're going to say out, which is 4 times whole. Is whole 8? No, it's not. Whole is 4 plus 8. So 4 times 12 is equal to 3 times. Okay, now you have to be careful here, because whole, children, when we solve for whole, is okay. So we're going to do this. I'm going to make a big X up here. 3 times X. And when we solve for that, kids, what we're going to end up with is the whole line, right? Because that's what we're solving for. We won't end up with this to this, but we can sure get there from that. So let's do this. So 4 times 12 is 48 is equal to 3x. 48 divided by 3. 16. Okay, so sorry about that. So 16 is equal to x. So the question is that the answer? No, it's not. 16 represents whole, doesn't it? We have just solved for whole. So to find this portion, we'd have to say 16 minus 3, which would then be 13. So this is 13. Alrighty? So those are your 3 possibilities. Those are the 3 theorems for this section. Got it? All right, kids, be good, be sweet. I guarantee you by this, well, no, I'm not going to say that. I was going to say I'm going to see you tomorrow, but then that would be very confusing to you, because I'm not seeing you. When you see this, I won't be seeing you. All right, just now I'm thinking about you. All right, bye, kiddos.